Welcome to another edition of Comet Algebra. This video is for Algebra 1, Chapter 5, Section 5, Function Rules. We'll start with just a little bit of review. If you're given a certain domain and you're asked to write a set of ordered pairs to represent each equation. So here's the domain. It is limited to only these 4 points. So you take them one at a time and plug it into the x to find the output. And we're supposed to write them as ordered pairs. So if the input is -1 with the x, put in the -1 where the x is. -1 times -4 is +4, so the output is 4. The next input is 0. 0 times anything is 0, so that's the output. The input then is 2. The output becomes -8. And if the input is 5, the output is -20. So that's the set of ordered pairs. And since we are asked for a set, I really should put that list in set notation. Now what I want to review right here, g of x. Part of the reading lesson we learned in algebra, g of x and f of x or h of x, whatever, the first letter right here is just the name. It's the name of the function. This one is called g. And g is telling us to take the input and add 4. So g of x, f of x, any function notation like that is interchangeable with y. So I wanted to remind you that this is the same as y. And we can write, I'll be writing them both ways, so we need to get used to that. And I don't know if we need to do another example of input. You put in each element in the domain and you get an output. So now let's look at the definition we need here. A function rule. The word rule is an equation. That's what I would like you to remember from this. The book uses the word rule all the time, so when they're asking you for a rule, they're asking you for an equation. An equation that pairs each number in the domain with one in the range. In other words, it tells us what to do with the output. What to do with the input to get the output. So again, rule is equation. Please know that. In this example, we're given a domain and we're given a function rule. Here's the rule. We are asked to do several things. They want us to represent this function as first a table, a set of ordered pairs, then a graph, and then a mapping diagram. All these things. So let's just go one at a time. If you remember a table, I sometimes call it a T-chart, where we set up an X and a Y. We put in the domain, of course, is the X values, so we'll put those in the table. And then one at a time, plug them in as the input and find the output. So -3 times 3 is -9, and -9 plus 2 is -7. Putting in a -1, I get a -1. Check my math here. Plug in a 0, I get 2. Putting in a 2, 6 plus 2 is 8. Putting in a 4, 12, 13, 14. I would like you also to know that sometimes your book puts a table sideways in this format. And they don't always put a y here. Sometimes they'll put f of x. But you know that f of x and y are the same thing. So again, the input would be where the x is, and then the output would be where the f of x, which is the same thing as y. All right, so we'll check this off. We're done with the table. Next thing they want is a set of ordered pairs. Well, let's just take them off the table. So the set of ordered pairs for f for this certain domain is -3, 7 in pairs, -1, -1, 0, 2, 2, 8, and 4, 14. And again, it's in set notation, but I still can't draw those brackets very good. So I'll check that off my list. Ordered pairs is done. Next thing we need to do is a graph. So now doing the graph, take those ordered pairs from the table and just graph them. So I have -3, -7 would graph right about there. Negative 1 is here. 0, 2, about there. 2, 8. And I can see I'm not really going to have enough room for 4. 14 is going to be like way up here somewhere. So after graphing these points, I'd like to ask you a question. Should I connect the dots and make this a line? And in class, a lot of people said yes, but actually it's no, because we have a domain right here that's very limited. It is only these points. So this has to stay a discrete graph. Just these points are the graph. The domain does not exist in between, for instance, nowhere in here. There is no between 0 and 2. So just the dots, do not connect the dots this time. So we'll check off graph off our list. And now I have placed the x values for the mapping diagram in the first circle, the x circle. I put the y values in the range. So just to review, this is the domain, and this one is the range. And then the arrows go from the input to the output, and mapping the 0 to the 2, 2 to the 8, and so on. So now we're done with the mapping diagram. This is just showing one function in multiple ways. All right, this is kind of an interesting function to look at. It's the absolute value function. So we're going to graph it. My advice to you, when you pick some x's to choose to use for your input, make sure you pick some negatives or you're going to miss an interesting part of this graph. So we're going to do this old school, and then we're also going to do this. I'll show you how to do it on your calculators too. So first the input output. Put -3 in for the x, and the output is +3. Likewise here with the 2, -1 is 1, 0. But when you put a positive into an absolute value, it stays positive. So let's graph these now. So here at -3, we're up here at +3. At -2, we're up here at +2. -1, -1, I'm sorry, -1, +1, 0, 0, 1, 1, 2, 2, 3, 3, and this pattern would go on forever. Now, do I connect the dots? And the answer is yes. This has no limits on the domain, so the values exist all in between these dots. So I do connect it, and that line comes up that way, and this line comes up this way. Wow, look at that. I drew straight lines. Amazing. And this becomes a V. It looks like a V. Kind of an interesting graph. Now, if you're interested in looking at this on your calc screen, you can graph it. First, go to the y equals screen, so punch that key. And then when you're sitting there on the y equals screen, we need to go get the absolute value. And you find that, punch the math button. Don't select anything in math. Arrow to the right with your arrow keys to num. I think that's short for numbers. And under numbers, then, a whole menu will appear. And I believe choice 1 says abs. If you select that, it'll bounce you back to the y equals screen, and then you'll have to fill in. It'll just, have y equals, and then most calculators, it'll actually put the absolute value symbols, and you just need to punch the X button and put that inside and graph it. And like I said, it's kind of interesting. It makes a V, and we'll be doing much more with this later. Next example, we are asked to write the function rule. Remember, the word rule means equation. So we have to write the rule by looking at the table, and this can be very challenging. It can be easy for some and difficult for others. So first thing we're looking for is patterns. I'm noticing that we're counting by ones on the X. That always makes it easier when you're going by ones to find the pattern. And then the pattern here, as we go up the f of x or the y, we are noticing we are adding a 3 each time. So that is important. So now you're picturing a y equals, which is a rule. what are we doing to each x to get the y? And if you'll notice, this 3 is important. So most people can see this and figure out 2 times 3 is 6, 1 times 3 is 3, and so on. So the rule is 3x. Now, this can be very frustrating if you don't see the pattern and you don't know what it is. And that's why we had the discussion with the last part, the last section of the regression lines. I wanted you to have another option. If you can't see the pattern, you could enter this in list 1, you could enter this in list 2, and if this is linear, which if you looked at the scatter plot it would be, you could just go to the stat, the calc menu, and you could do the linreg. And the linreg, linear regression line, your calculator would tell you this. I wanted you to have an option if you can't see the pattern. In this example, in our multiple representations here, we're asked to find the function rule by looking at the graph. Now, I did my best to draw a graph without graph paper, so I hope the x's can kind of show us where this line crosses an intersection. So if you have a graph, there's different ways you can do this. If you know the y equals mx plus b, you can use that to write your function rule, which is your y equals. If you don't, you need to pull some points off the graph. Now, I don't know if I did a good job of making this clear, but let's pull some points off. 1, 2, at -4, we're down here at -1. So I'm going to put that into my table. Over here at -2, we're at 0. At 0, we're up here at +1. At 2, we're up here at 2. And then at 4, we're up here at 3. So now let's look and see if we can see the pattern here, if we can figure out the rule or the y equals. So I notice the x's here. The x's are skipping. We're adding a 2 here, so it's not counting by ones this time. And that makes the pattern a little more challenging to see. Looking over here at the y's, from -1 to 0, from 0 to 1, from 1 to 2, and so on, we're adding a 1. So now I remember being in school and being very stuck and not knowing how to do this. I knew that the 2 was important and I knew that the 1 was important, but I didn't always figure it out. You're multiplying the x by something and something with the y. And right now in class, some people will see it. They have already seen the pattern. If you have, that's great. If you haven't, you can always enter this, which is why we learned regression lines. You can always enter this in list 1 and list 2. Obviously, this is linear, and you could look at the linreg. And what we're doing here is we are taking half of x and then adding a 1. And like I said, some of you will see that from the table. You don't need to waste all that time punching it into the calc. And if you see it, that's great, and you can write the function rule. If you can't see it, you have the option of using the calculator. All right, once again, I did my best to show you the ordered pairs on this graph. They want us again to find the function rule. So let's pull the ordered pairs off. Here at -3, I'm up all the way up at 9. So -3 maps to 9. -2 here is up at +4. 0, 0 is graphed. And then here at, oh, I guess I forgot a point. I forgot the -1. At -1, I'm up at +1. And now I'll get the 0, 0 in here. Over here at +1, I'm up at +1. Here at +2, I'm all the way up at 4. And at 3, up to 9. So now looking at the shape of this graph, it is clearly not linear. You could not use lin-reg to do this. Would not work. So either you're going to have to look at the table and see the pattern to write the y equals, or you're going to have to know what this shape is, this curvy shape that looks sort of like a U. And if you knew that this is a parabola and that the type of line it's called on the calculator, this is a quadratic regression line. So it's a quadreg. So if you're going to use your calc, you'd have to know that. But perhaps most of you have already seen what are you doing to x to get y, and every time we are squaring it. So I just wanted to show you this. It's not always linear. You can't depend on that. You have to look at the graph and rely on your knowledge of the shape. All right, I think that's all the knowledge you need for section 5.5. So have fun with math.